All right, good morning. This is the 18th of March. We're going to look at the sine rule. This is primarily for HL, but SL will need to know it. So there's no harm in SL students watching this. I actually encourage you to do so. So, all right, so quick note. We use the sine rule to calculate unknown sides or angles in any triangle. Okay, so before with trigonometry, regular trig, it has to be right angled. With this, it does not have to be right angled, okay? So the sine rule is, so I'll give it to you first. If I've got any triangle, I'll draw one. And I'll label like what we did yesterday. So that's angle A, side A, angle B, side B, angle C, side C. That is a C. Yeah, it's my my lowercase c. I give it a little tail. Okay, so the sine rule says sine A over A equals sine B over B equals sine C over C. And we're going to, I want us to get into the habit of thinking we're going to use this one. We're going to use this one to find angles. Or it also says A over sine A equals B over sine B equals C over sine C. And this one we use to find side lengths. Alright, so it looks worse than it is. Do you remember doing this from last year, Ari?
Yeah.
Cool. So what we'll do is we'll do an example first, and then just so the SL ones can watch it, and then we'll do a proof of the sine rule for you guys. So let's say that this is 65 degrees. Let's say this is 15 centimeters. And let's say that this is what we want to find out. And let's say that this is 50. All right, so to use the sine rule, we want to find this side. Okay, so we want to find the side, so this is the way we're going to set it up, okay? We're going to set it up using these formulas, this formula here, okay, with side length on top. So I don't really bother so much with the formula. Well, I do, but I don't really refer to it too much. But I've got the side length on top. So side A divided by sine of A. Okay, so that's the angle opposite it. So side x divided by sine of 65, good, because that's the angle opposite it, is equal to 15, because that's the length of the other side, divided by sine of 50. Okay, we don't know anything about the other side, so we don't worry about the last part. Okay, so this is all I'm dealing with. I want to work out what x is, so how do I get rid of the sine 65 on the bottom? Multiply by the other side, good, so I've got 15 times sine 65 divided by sine 50. We whack this into our calculator. What did you get, all right?
17.7, 17.8.
17.8 centimeters. Good. All right, so it's not particularly very difficult. I'll just do another one showing how we work out the angle. So let's say we know that this is 22 centimeters. Let's say we don't know what this angle is. Let's say that this is 14 centimeters and this is 35 degrees. So this time we're going to use the top one because we want to find the angle. So this is the formulas. So it's going to be sine of what, Ari?
X.
Yep. Divided by 22 is equal to sine 35 over 14. We don't know the other side, so this is all the information we need. How do we get rid of the 22 on the bottom?
Multiply to the side.
Yep, multiply both sides by it. So I get 22 sine 35 equals 14. Okay, and then here's how I would just do this on the calculator. So I've got 22 sine 35, enter, divided by 14 equals that. And then how do I work out what x is?
Do inverse sine.
Yep, you're going to have to do inverse sine of all of that. So of all of that number, now remember you don't want to lose points for your rounding, so I would just make sure you keep that on your screen, so that's negative 0.67 and so on, but you use the whole thing in your calculator. So inverse sine, hopefully I've picked a decent example. No, I haven't. Actually, let me just check because I need to be in, there we go, in radians. Yeah. Okay. Okay, so back to 22 sine 35. That's just Ari coughing.
Sorry, guys.
So 0.901. 0.901. And you will realize, okay, if you're in the wrong, if you're in radians and you shouldn't be, you'll realize because you'll get a strange looking answer out. So inverse sine of this, and we get, yep, that looks a lot more sensible for an angle, 64 degrees. Right, so SL, in terms of you guys, SL can practice stuff from your book, page 485, and this is finding the angle first, and then it moves on to finding the side length. Okay, so page 485 and 486. Have a look at this and hit me up if you have any questions. Okay, I'm going to keep going though and talk about some stuff for HL. Feel free to watch if you so wish, SL. So let's look at the proof of the sine rule. So this is for HL. And those of you interested in this at SL. So we're going to start off with a triangle. It's looking so well. Are you sick?
No. This is from the boy being sick. I've got mucus in my throat, and it's a wet cough. It's not dry, so it's not corona. Make sure I clarify that.
Yeah.
It's tickling my throat. So. That's all.
Okay, so we got A, B, H. This is little c, big C. This is a right angle. This is D. This is little A. All right, so in triangle ABD, I can see that sine of A is equal to what, Ari?
Sine of A.
Yeah, in triangle ABD. Is equal to what?
C over H, sorry.
Is equal to sine of A is equal to
Equal to C over A. Oh, sorry, H over C.
H over C, okay, good. Opposite over hypotenuse. And I can rewrite this just by, I can say that, well, H then is equal to C times sine A. By the same token, in triangle CBD, sine of C is equal to
H over A.
opposite over hypotenuse, good, H over A. So that tells us that H is equal to
A times sine C.
A times sine C. Right, so C sine A is equal to H. A sine C is equal to H, so both these things are equal to each other. And if that's the case, then I can divide both sides by sine A, divide by sine A. We'll do this in 2 steps. So I get C is equal to and then divide both sides by sine C. Sorry, and I should just make these are little c's. So I end up getting little c divided by sine C is equal to A divided by sine A. Okay? Now we can obviously extend that if we let me show. So if I take the same triangle, that's easy enough for the first part, yeah. So if I extend this up slightly, like so. Meter. B. Put them up here. And this time I'm going to move this over. So we've just taken this previous triangle and we have extended this line up, okay, and we're going to do a similar type thing. We're going to say in triangle BCE, and triangle BCE, so this little one, sine of B is equal to no, careful. Oh, so I'm looking at this is the triangle I'm looking at, BCE.
Oh, the small one right here.
Yep, and this is a right angle here. So sine of B is opposite, which is H over. Yep. So big H over A. Also in triangle ACE. ACE. Sine of A is equal to opposite H over B. Okay, so by the same vein, if I rearrange each of these, I'm going to have H is equal to A sine B, which equals to B sine A. So that's just rearranging just like what we did up here. And this is going to give me A over sine A is equal to B over sine B. And because A over sine A also equals C over sine C, then this equals C over sine C. And that is our sine rule. Yeah. Now, I've never seen them ask you to prove this type of thing, but I would just keep it in your mind. It's not too difficult. They might guide you through it. So just be aware. All right, so I'll pause there. No, I won't. So HL. So HL, there is one other thing that we need to do, but I don't want to do it just yet, because I want to do it with SL as well. Well, you could have a look at page 396. And if you have any questions on any of it, you can ask. There's a little kind of ambiguous thing that you may come across, but we can discuss it, okay, when we get to it. All right.